All right, so last one got cut off. So looking at the answer for this part over here, we did 4,800. Second ln is going to give us e with the exponent, 0.065 times 3. Gives us that the balance would be, after 3 years, $5,833.49. All right, so the last one is using the calculator to find the intersection. So it doesn't really help us by labeling it, but we can reason through what these numbers are. So here, you deposit $700 in an account that pays 2.75% annual interest. How long does it take for the balance to reach $2,000 when compounded continuously? So I want to know, so I'm going to put the 2,000 here because that's what I'm looking for. And I want to make my equation over here. So my A value is 700. And I know to use the E because it says continuously. And in the numerator, I'm going to multiply the exponent, I'm going to multiply the percent, which is 0.0275. And I don't know T, that's what I'm looking for, so I'm going to make it with an exponent of X. So on this graph, this one actually isn't 0 to 10 because in order for it to grow that much, it needs to sit in and collect money a long time. So it is going to start at 0 here. But then these don't count by ones this time. We need it to go all the way to 50. So these look like they count by 5s, 5, 10, 15, 20, 25, 30, 40, 45, 50. Because it's going to take quite a bit of time for it to, maybe not 50 years, but it's going to take more than 10 years. So we need to make it a little bigger. All right, so this is my starting amount, 700. And it looks like it's just above that one, so that one's probably 500. This is 1,000, 2,000, 3,000. It looks like it goes all the way up to 3,000. So if we draw the horizontal line of the 2,000, it would be 5, 1, 2 would be right here. That's the point of intersection that I'm trying to find. So let's go adjust our window and graph it in the calculator. So over here, the y equals, let me clear this last one. We want to do 700 e to the 0.0275 times x. And we want to know when does that reach 2,000. So if we graph it, if we just hit graph, it's probably not going to be the window that we want from before. So I'm going to go through and change it 0 to 50. And again, it's counting by 5s, and that really doesn't make a difference when you graph it. And then on the y, it's 0. And the top number is 3,000, because you always want it to be higher than what you're looking for. And this one counts it by 500s, but again, without the scale, it'll still graph it for you. So this is the graph that was given. Here comes my 2,000. And to find that point, we do second trace number 5, enter, enter, enter. And we get that it takes quite a bit of time to increase that much. So time is 38.17 years. And that's with a pretty big percent rate. So hopefully you would be adding along the way. If you have this in the savings account, you won't just let it sit there at 700. But even at 700, you still get money. It just takes a long time. So more than almost triple your money. All right, so that's it for the 4 models. So in the end, I will give you the 4. You just have to know when to use them. So when do you use the 4 models? PERT is when it's continuously. We'll come back to that page. The compounded interest is when it gives with a certain frequency. And then the growth and decay, you have to know whether it's saying growing or decaying for population or for cost. All right, so now you can work on your homework, finishing the one for tomorrow. If you're done with that one, then start the new one.